For this project, Eric Mormon led a small team of ignition developers at Flexware Innovation. We were approached by Belden to develop an OEE solution that could be used not only at the Richmond, Indiana plant, but eventually across the enterprise. In order to develop a scalable and configurable OEE solution, we leveraged SparkMES, which is a framework built by Flexware Innovation to provide a quick start for building scalable MES applications. SparkMES is a series of perspective screens, database stored procedures, tables, background logic, and UDTs that all come together to give us a starting point for rapid development of customized MES solutions for customers. And once SparkMES is deployed, it can then be 100% customized for the customer, allowing us to build Belden's dream application and not constrain them inside a box. The greatest challenge with the Belden solution was getting all the data up to SparkMES. Luckily, Ignition has outstanding connectivity drivers that helped us along. The Belden equipment at the Richmond plant had many variations in how they were programmed and how we could connect to them, including OPC UA, Modbus, and even database connections to pull information from device. This is possible by utilizing Ignition's wide array of drivers, of course, as it allows for easy connectivity to Allen Bradley PLCs and Modbus connections. We then used cross-database queries using SQL Server to pull data out of the database connections. Once this data was in Ignition, we could use Ignition's tag layer as well as SparkMES's UDTs to quickly pull the value in and get insights into the OEE data. To do this, SparkMES provides a built-in OEE UDT, allowing users to pull in data for in-feed, out-feed, scrap, and status codes and put that into the database tables to be stored. This UDT works off of reference tags, so it can be easily embedded into any tag structure that may already exist for the customer. In this case, Belden didn't yet have a tag structure, so instead, we built a series of UDTs for every type of machine that we would be connecting to and simply embedded the OEE UDT inside of that. This provided flexibility with how UDTs were created and, again, not be limited to a specific structure. Once the data made it into the OEE UDT, the associated tag chain scripts allowed for forwarding of data to the data model in the SQL server for SparkMES. And once there, a series of views and stored procedures provided a simple OEE data interface that could be used for reporting in both Ignition and external interfaces such as Tableau. For the screens, we took a different approach to UI design. We used a dark theme card layout with the navigation bar at the bottom, resembling a common Windows theme users might be familiar with. On this taskbar, there are 3 different areas. In the middle are nav icons for every screen that you would access in this workstation. On the left is a flyout menu that lets you quickly navigate around the screen or the workstation that you're on. This can change depending on the screen, but for this screen, it is showing our production model so that we can more easily navigate between locations from this screen. And on the right is a link to any help documentation for this workstation or screen. We used a card layout so that we could easily organize the information. For these screens, we decided to heavily use the dashboard component. We felt the dashboard component gave us a sharp card layout out of the box, and it also heavily uses embedded views, which is a standard we like to follow. We use embedded views that have common inputs, in this case, location, start date, and end date. This allowed us to build up a widget library while building the dashboard that could then be reused as we and the customer build new screens. This shows the line overview screen. This screen's main purpose is to display on a large TV over every area of the plant and also on the screens of any line lead or engineer who may want to see how the plant is operating. This screen is designed to show high-level data, but also allows users to drill down into different levels of the plant. With SparkMES, OEE calculations propagate up and down the plant as needed. At the top of this, you see the production model navigation. Right now, we're viewing the screen for MS to M9 OEE statistics. However, if we wanted to look at M136 OEE statistics, we could click on that pill and the whole screen would change to the context of M136. Additionally, you'll see it shifted left, and now we see pills of every child location to M136. The color of these pills tells a bit about the status of those machines at a glance, green being running, red being down, and yellow being running but running under the target rates. If we wanted to navigate back up to M6 through 9, we could just click on the pill. On the top bar of this screen, we see different OEE stats for this location, such as the availability, performance, quality or yield, and the OEE stat. In the table, we also show useful information about child locations that we're currently viewing. In this case, all the different machines. We also see some useful information such as their status codes, their current item and order number they're running, their target versus actual run rates, and then their own OEE stats. However, if we wanted to see a bit more detail, we could click on the location we want to learn more about. And now that we're at the machine level, we see a more graphical representation of the different data that appears for this machine. At the top, we have a downtime bar that shows over time when you were running versus when you were down, and you can see exact durations if you hover over the different events. Here we show the OEE stats. In this middle chart, we show the OEE stats for this location, calculated every hour over the last 7 days, allowing you to see trends in the OEE data and see big dips that need further investigation. And on the right, we have one of the simplest components, but what most people really look for with OEE, the downtime Pareto. This Pareto tells us what our heaviest hitters are both by total downtime cost and by the total number of occurrences. This Pareto quickly tells what events need to be addressed first and will have the biggest impact as we try to fix problems and raise our availability. This screen is our operator dashboard. It shows similar information as our line overview dashboard, but it's meant to be tailored more to the operator experience and how their machine is running. Additionally, this would allow operators to supplement any needed data from the machine since this is designed as an enterprise solution. This allows for different equipment to have different contexts. For example, some machines tell us information about the order number and item number they're actively running, while others can't. In the case where the machine can't tell us, the operator could use the pencil icon and then provide information about the order that's currently running. Once we get the order number, we'd be able to pull in what the actual item number being run is. Additionally, some machines don't provide us good downtime codes or downtime codes at all. If a machine can provide downtime codes, we would pull those automatically from the PLC, as this is the ideal way to do OEE. However, in a case where you're getting no downtime codes, the operator can change the downtime code by clicking the pencil icon by the reason code. The most common occurrence we faced at Belden was machines that are semi-automated, machines that provide us some downtime codes but need more context. For these cases, we would have unknown events that occur, and when these events happen, we would prompt the user to give us more information about what's going on. You can see here that we're being prompted for events in the queue that we need to resolve. Clicking on this shows us a doc of every unknown event that's occurred. Clicking on any one of them displays the same doc presented when the event happened live. From here, the operator has a series of tabs where they can choose the event that occurred. They can also add comments to provide clarity on top of what the buttons allow. Once they choose an option, reason codes would be added to the event, and then they would be prompted back to the main screen. One of the biggest considerations when developing an enterprise solution is how to scale it across the enterprise. The goal should be a solution that is easily scalable and easily configurable, not only by people with in-depth ignition knowledge, but by those without experience as well. In order to do that, we provided a good set of perspective-based configuration applications that operators could use to configure how SparkMES OEE will run. This meant that the only ignition knowledge our customers needed was how to connect the device to ignition along with the ignition tag browser, both of which have thorough online documentation and are easy to use. This screen is the main screen for configuration of how OEE will run inside of a plant. On the left, you have the tree of the Richmond plant's production model. This tree does not have rigidity as to how the levels are defined. This concludes our brief overview of Belden's solution. We were privileged to work with Logan Cooper, Belden's Director of Quality and Lean. Logan had this to say about the project.
So with the help of Flexware, we designed and implemented a system that records and displays this real-time performance and OEE data that flows directly from our equipment into dashboards that allow us to track and alert key people to conditions that we need to address in the real-time moment. All of that data is flowing through a backbone of Belden equipment, and overall for this project, we've seen an improvement in our OEE from about 45% at our jump-off point to a sustained 55% over the course of this implementation. We've also seen overall just an improvement in the solution ideas we have for problems that we face on a daily basis. So this injection of information and this injection of technology with ignition at its core has really improved our ability to solve problems, look at problems differently, have more intelligent data that is being able to use to make better decisions. And I think ultimately that's driving performance, but also creativity in the long run.